So we continue with the video lectures. This is topic 3, bonding. Bonding is an extremely important concept. Elements will form a bond in order to release energy. The releasing of energy is exothermic, so the compound will have less potential energy than before, and it will then become more stable. We really have to understand the difference between ionic and molecular bonding. Ionic substances, properties, have high melting points, and they conduct electricity in solution or melted. Covalent compounds have a lower melting point and do not conduct electricity. So that's a classic question that they ask. Nonpolar dissolve nonpolar, polar dissolves polar. We sum this up as like dissolves like. So a bond forms when electrons are transferred, which is an ionic bond, or when they are shared, which is a covalent bond. So ionic bonds form between metals and nonmetals, whereas a covalent bond forms between two nonmetals. A metallic bond, the third type, is just the bonding found in metals. So if you are a metal by itself, it is metallic bonding. We can form double or triple bonds during the bonding process. Polarity of a molecule is based on its shape. So if you are asymmetrical, you are a polar molecule. If you are symmetrical, you are a nonpolar molecule. When an atom gains an electron, it becomes a negative ion and its radius increases. This happens in the nonmetals. When an atom loses an electron, it becomes a positive ion and its radius decreases. This happens in the metals. So atoms gain stability by bonding with other atoms. They are stable when they have a full valence electrons, which is the octet rule, 8 valence electrons, although hydrogen and helium only need 2. So NaCl, which is a metal and a nonmetal, is ionic. And if we drew the electron dot diagram or the Lewis structure, we would have the sodium ion attached to the chloride ion. The chloride ion has 8 valence electrons and a minus charge by gaining the electron that sodium lost. And we have an attraction of opposite charges called an ionic bond. NH3 is between two nonmetals, so this is a covalent bond. When we did the Lewis structures, we count valence electrons, excuse me. So 5 plus 3 equals 8 valence electrons, group 15, and group 1 for hydrogen. We start usually the first thing in the middle, then we attach with single bonds. But the octet rule says that nitrogen has to have 8. We've used 2, 4, 6, so we have 2 more electrons that we distribute. If we look at methane, methane has polar bonds between the carbon and the H because they're different, but because it has symmetry, it is a non-polar molecule. HCl has polar bonds, but since they are different atoms, there is no symmetry. It is a polar molecule. we skip to the next page, the noble gases have filled valence electron levels, so they do not normally bond. We can cross off number 10. Number 11, electronegativity is how strongly an atom attracts electrons. This is found in Table S. If the atoms are the same, the electronegativity difference will be 0, and it will be a nonpolar bond. If it is greater than 1.7, it will be ionic. And our bonding guidelines: metals react with nonmetals to form ionic compounds. Nonmetals form with nonmetals, bond with nonmetals to form covalent compounds. If you are an ionic compound with a polyatomic ion, like Na3PO4, this is the classic Regents question. Between the sodium and the phosphate is an ionic bond, but between the P and the O of the phosphate ion is a covalent bond. So it has both ionic and covalent bonds. Intermolecular forces are the forces between different molecules. The strongest of these is the hydrogen bond. Hydrogen bonds exist between hydrogen and O, F, or N. So NH3, H2O, and HF. And these tend to have higher melting and boiling points than those forces that are not hydrogen bonds. So our three types of forces are dispersion, which occurs between non-polar molecules. So hydrogen is attracted to another hydrogen molecule through dispersion, which is a very, very weak force. Dipole attraction. The force of attraction between polar molecules is stronger than dispersion, but the strongest of the three is the hydrogen bond. That finishes topic 3. I think today we're just going to do topic 3 and topic 4, and that'll be enough. So we're only going to do 2 topics total. So if we move ahead, topic 4, matter, phases, and the gas laws. Matter is classified as a pure substance or a mixture of substances. Elements and compounds are the only things that we consider to be substances. Elements and compounds. A mixture are composed of 2 different substances that can be physically separated. It can be homogeneous or heterogeneous. If it's homogeneous, it's a solution. Substances in a mixture retain their original properties. They can be separated, and they can be filtered or distilled. Filtered is a solid within a solution. Distillation is between 2 liquids with different boiling points. An element is a substance with the same atomic number. cannot be broken down by chemical changes. A compound is two or more elements bonded together. So all of this pretty much makes sense. They can be broken down. A physical change results in the rearrangement of particles, like freezing or boiling. So all phase changes are physical changes. A chemical change results in the formation of something new and different. If you burn paper, that is a chemical change. If you rip paper, that is a physical change because it's still paper. We should know the properties of a solid, liquid, and gas. Solids, definite shape, definite volume. Liquids, no definite shape, but a definite volume. Gases, no definite shape, no definite volume. And a heating curve is extremely important, which I'm going to draw one down below. So helium and H2O are substances because they are an element and then a compound. Helium is an element. Water is a compound. Two elements chemically combined. Phase changes are physical changes. For instance, solid to gas. Burning is a chemical change. And a phase diagram has a diagonal, flat, diagonal, flat, diagonal. The diagonals are the phases, solid, liquid, gas. The flats are the phase changes, melting and boiling. When the temperature goes up, the kinetic energy goes up. When the temperature stays the same during a phase change, the potential energy is increasing. Heat of fusion and heat of vaporization, both of these problems we've done. We have to use the reference tables to find the values. Fusion is the energy needed to melt ice. Vaporization is the energy needed to boil water. Specific heat is the energy required to raise 1 gram of a substance 1 degree Celsius or Kelvin. We should know our combined gas law. If we increase the pressure, we will decrease the volume, which is inverse. If we increase the temperature, we will increase the volume, which is a direct relationship. And if we increase the temperature, we increase the pressure, which is also a direct relationship. An ideal gas law explains the behavior of gases. We have a mistake here. A real gas is most like an ideal gas when there is a high temperature and when it is at low pressure. You do have to know the kinetic molecular theory that gas particles are in random motion. They have no forces of attraction between them. Each particle is negligible compared to the volume of the container. And collisions result in a transfer of energy from one particle to another, but there is no net loss of energy from the collision. So there's a conservation of energy. Equal volumes of gases at the same temperature and pressure have equal number of particles. So if we have 22.4 liters of helium or hydrogen and 22.4 liters of helium, that's the magic number, which represents a mole of each, there will be a total of 6.02 times 10 to the 23 particles in each. So equal volumes, equal number of moles. Our combined gas law is P1V1 over T1 equals P2V2 over T2. If the temperature stays constant, we can cross off the temperature terms, and we're left with P1V1 equals P2V2. If the volume is held constant, then we're left with P1 over T1 equals P2 over T2. Real gases equal ideal gases at high temperature and low pressure. So that takes care of unit topic 4. That's it for today. We hit the 16-minute mark. So we'll continue tomorrow. And remember, each of these gets checked when you walk into class. So have a great day, and we'll see you tomorrow. Bye.